Imagine waking up one morning and finding your entire city buried under miles of ice. The ground you walk on frozen solid, the oceans shrinking back, and giant mammoths roaming where skyscrapers once stood. Sounds like a science fiction movie, right? But this is not fiction. This has actually happened to Earth not once, not twice, but again and again. Our planet has slipped into deep freezes, called ice ages, many times throughout history. And the biggest question is, why do ice ages keep returning? To answer that, we need to travel back in time, millions of years back. Earth hasn't always looked the way it does today. In fact, for most of its 4.5 billion year history, Earth has been much warmer than it is now. Tropical plants grew in places that are icy today like Antarctica. But then, at certain points, the planet suddenly plunged into extreme cold. Entire continents became buried under thick sheets of ice, some of them more than 3 kilometers thick, that's taller than the world's highest mountains. This cycle of freezing and thawing, of ice advancing and retreating, has shaped everything. The land beneath our feet, the oceans we depend on, even the very path of human civilization. Without these repeating ice ages, humans might never have existed in the first place. So what triggers these icy eras? Why does Earth sometimes decide to lock itself in a freezer for tens of thousands of years, only to thaw out again? The first piece of this puzzle lies not on Earth, but far above us in the sky. Every planet in the solar system orbits the sun, but Earth's orbit isn't always the same. Sometimes it's slightly more oval-shaped. Sometimes it tilts a little more or less. These changes may sound small, but they are huge when it comes to climate. Scientists call these shifts the Milankovitch cycles, named after a Serbian scientist who figured them out in the early 1900s. Here's how they work. Earth doesn't just spin like a perfect top. It wobbles slowly like a spinning toy about to fall. That wobble changes how much sunlight reaches different parts of the planet. The tilt of Earth also changes over time. More tilt means hotter summers and colder winters. Less tilt means gentler seasons. And finally, Earth's orbit stretches and squishes very slowly, over tens of thousands of years, changing how much sunlight reaches Earth as a whole. Together, these cycles act like a gigantic cosmic clock. When the conditions line up just right, they push Earth into a new ice age. Here's a mind-blowing fact. Right now, we live in what's called an interglacial period. That means we're between ice ages. The last one ended about 11,700 years ago. Back then, massive ice sheets covered most of North America, Europe, and Asia. New York City, London, and Berlin, all were buried under ice. Humans survived by spreading into warmer regions, hunting mammoths, and carving out a life in the harshest conditions imaginable. Without the end of that last ice age, we wouldn't have farming, cities, or even the world as we know it. The melting of ice created fertile lands, filled rivers, and gave birth to civilizations. But here's the catch: the cycles haven't stopped. Earth is still ticking, still spinning, still wobbling. Which means one day in the future, the ice will return. But before we talk about the future, let's uncover the strange and surprising evidence from the past. Because locked inside rocks, mountains, and even the ocean floor are clues about the hidden history of ice ages, and they tell a story far more dramatic than you can imagine. When scientists first began studying Earth's history, many thought the idea of ice ages was impossible. How could entire continents freeze? But then they stumbled upon strange evidence: giant boulders sitting in places they didn't belong, valleys carved into U-shapes, and scratches etched deep into solid rock. These weren't ordinary marks of erosion. They were the fingerprints of glaciers. Glaciers are like slow-moving rivers of ice, grinding across the land with unstoppable force. Over thousands of years, they scrape mountains flat, dig valleys, and carry massive rocks across great distances. When they finally melt, they leave behind these mysterious clues. In the 1800s, a Swiss scientist named Louis Agassiz looked at these signs and made a bold claim: the Earth had once been covered in ice. At the time, people thought he was crazy. But as more and more evidence piled up, his theory became undeniable. Earth really had frozen over, again and again. Imagine standing in New York City during the last ice age. Instead of skyscrapers, you'd see a towering wall of ice stretching across the horizon. The Hudson River would be buried under hundreds of meters of frozen water. Central Park? Nothing but ice and wind. And this wasn't just New York. Chicago, Boston, Toronto, all swallowed by glaciers. Across Europe, ice covered Scandinavia, Germany, and Britain. In Asia, northern China and Siberia were frozen wastelands. And yet, life kept adapting. Mammoths, saber-toothed cats, and giant sloths thrived in this icy world. Early humans braved the cold by making clothes from animal skins, building fires, and moving south toward warmer lands. Ice ages shaped human survival, forcing us to innovate and adapt. But here's where it gets even more fascinating. The last ice age wasn't the only one. In fact, scientists have discovered that Earth has gone through dozens of them in just the past 2.6 million years. And if we go further back, there were even more extreme freezes. Around 700 million years ago, Earth experienced something called snowball Earth. During this time, scientists believe ice may have stretched all the way to the equator, turning the planet into a white marble floating in space. How do we know this? The answer is hidden in rocks. Deep inside mountain ranges and buried beneath oceans, geologists find tiny fossils, trapped gases and chemical fingerprints that tell the story of ancient climates. Even microscopic bubbles of air frozen inside Antarctic ice cores hold secrets. Mini-time capsules of Earth's atmosphere going back hundreds of thousands of years. By drilling into the ice and analyzing these bubbles, scientists can measure past temperatures and even the amount of carbon dioxide in the air. For example, scientists studying ice cores found that major ice ages tend to happen roughly every 100,000 years. These rhythms match perfectly with the Milankovitch cycles we talked about earlier, the wobbles and tilts of Earth's orbit. When CO2 levels are low, the planet cools dramatically and ice sheets grow. When CO2 rises, the ice retreats and Earth warms. In other words, ice and atmosphere dance together, creating the repeating pattern of freezing and thawing. Here's another fascinating fact. The rise and fall of sea levels are also controlled by ice ages. During the last ice age, so much water was locked in ice sheets that sea levels dropped by over 120 meters. Entire land bridges appeared, connecting continents. Early humans walked from Asia to North America across the Bering Land Bridge, a path now buried under the Bering Sea. Without that land bridge, humans might never have reached the Americas. The story of ice ages isn't just about cold, it's about discovery, survival, and the incredible ways Earth transforms itself. But we're only halfway through the mystery. If Earth's cycles guarantee more ice ages, when will the next one arrive? And why, for the past 10,000 years, have we been living in such an unusually warm and stable period? The answer may surprise you. For the past 2.6 million years, Earth has fallen into a steady rhythm. Freeze, thaw, freeze, thaw. Each ice age lasts tens of thousands of years, followed by shorter, warmer breaks known as interglacials. But here's the strange thing. Our current interglacial, the one we're living in right now, has lasted unusually long. It's been more than 11,700 years since the last ice age ended. That's longer than most warm periods in Earth's recent history. What's keeping the ice away? To answer that, we need to look at what makes an ice age end. Normally, when Earth's orbit and tilt shift, summers in the northern hemisphere become slightly stronger. Glaciers, which have been growing for thousands of years, start to melt a little more each summer. As ice melts, it exposes darker land and ocean beneath it, which absorb more sunlight. This creates a feedback loop. The more ice melts, the faster Earth warms. Eventually, the ice age comes to an end, and a new interglacial begins. That's the natural cycle. But our current warm period is different. It's not just longer, it's also more stable. This stability is what allowed human civilization to rise. Think about it. Farming began only after the last ice age ended. When the climate stabilized, humans could plant crops, domesticate animals, and build permanent settlements. Rivers swelled with meltwater from retreating glaciers, providing fertile soil. This was the birth of agriculture, the very foundation of cities, trade, and modern life. Without this unusually long and stable warm period, civilization as we know it might never have happened. But scientists have discovered another twist. By studying ice cores and ancient sediments, they found that Earth should already be cooling again. According to the usual cycles, we should be slowly heading toward the beginning of the next ice age. Yet the opposite is happening. Instead of cooling, the planet is warming, faster than ever before in history. So what changed? The answer lies in human activity. For the past 200 years, since the Industrial Revolution, humans have been burning massive amounts of coal, oil, and gas. This releases huge quantities of carbon dioxide into the atmosphere. Remember how we said earlier that CO2 plays a starring role in ice ages? When it's low, Earth cools. When it's high, Earth warms. Right now, CO2 levels are higher than they've been in at least 800,000 years. This sudden spike in greenhouse gases is overpowering the natural cycles. In other words, the cosmic clock that usually sets the timing of ice ages is being disrupted by humans. If history had followed its natural course, Earth might have been on track to begin sliding into another ice age tens of thousands of years from now. But our influence has delayed it, maybe even canceled it, for the foreseeable future. Here's a striking fact. The ice sheets that once buried New York and London are now shrinking in places like Greenland and Antarctica. Scientists have measured that Greenland alone is losing billions of tons of ice every year. If all of Greenland's ice were to melt, sea levels would rise by about 7 meters, flooding cities across the globe. So, instead of asking when will the next ice age begin, scientists are now asking will there even be a next ice age at all? This question doesn't just affect the distant future. It affects us right now because the stability of our planet, the very climate that gave rise to civilization, is being rewritten before our eyes. But there's another layer to this mystery, one that reaches beyond human influence. Because if we zoom out far enough, beyond centuries, beyond millennia, we discover that ice ages aren't just shaped by Earth and humans. They're also influenced by forces far bigger than our planet. Forces written in the stars. To understand the grand story of ice ages, we have to step back and see Earth as part of something much bigger. Our planet isn't isolated. It's a tiny speck in a vast solar system, influenced by forces far beyond our control. And some of these cosmic forces play a huge role in deciding when ice ages come and go. Let's start with the sun, the ultimate source of energy for life on Earth. The sun isn't perfectly steady. Over time, its output changes slightly, creating warm periods and cooler ones. Sometimes the sun goes through phases of lower activity with fewer sunspots and Earth cools. During one of these periods, between the 1300s and 1800s, Europe and North America experienced what's called the Little Ice Age. Rivers like the Thames and London froze solid. Crops failed. Winters were brutal. This wasn't a full ice age, but it showed how even small changes in the sun's energy can shake human civilization. Then there are cosmic visitors, asteroids and comets. When a giant rock from space slams into Earth, the explosion can throw dust and ash high into the atmosphere. This blocks sunlight, plunging the planet into a temporary deep freeze. One famous example is the asteroid that wiped out the dinosaurs 66 million years ago. While that wasn't during an ice age, it shows how sudden cosmic events can dramatically reshape the climate. If a large asteroid struck today, it could trigger a nuclear winter effect, an Earth that cools rapidly with massive consequences. But perhaps the most important factor shaping ice ages doesn't come from the sky at all. It comes from beneath our feet. The very surface of Earth is in constant motion. Our continents aren't fixed. They drift slowly over millions of years, carried on tectonic plates. This shifting of continents can completely transform the planet's climate. Take Antarctica for example. Millions of years ago, it wasn't sitting over the South Pole. It was farther north and much warmer. But as continents shifted, Antarctica moved into its icy position at the bottom of the world. At the same time, South America and Antarctica separated, opening up the Drake Passage. This allowed a powerful current of cold water, the Antarctic Circumpolar Current, to begin circulating, isolating Antarctica and locking it into a deep freeze. That single geological shift helped trigger the modern ice age cycles we still experience today. Another key event was the rise of the Himalayas. When the Indian Plate collided with Asia, it pushed up the tallest mountains on Earth. These mountains began weathering, breaking down rock and trapping carbon dioxide from the atmosphere. Less CO2 meant cooler global temperatures, which made it easier for ice ages to begin. In other words, the very mountains we see today played a role in freezing our planet. Here's an incredible fact. Right now the continents are still drifting. Over millions of years, new mountain ranges will rise, oceans will open and close, and the balance of Earth's climate will shift again. This means the ice age cycles we see today are just one chapter in a much larger story of Earth's evolution. So when we ask, why do ice ages keep returning? The answer isn't simple. It's not just Earth wobbling on its axis. It's not just carbon dioxide. It's the sun, the stars, the continents, the oceans, all working together in a delicate balance. Our planet is like an orchestra, with each player adding to the rhythm of freezing and thawing. But this leads us to the most important question of all. Now that humans have entered the picture, pumping greenhouse gases into the atmosphere and reshaping the climate at lightning speed, what happens next? Are we preventing the next ice age? Or are we creating a new kind of climate crisis the Earth has never seen before? For billions of years, Earth has been a planet of extremes, burning hot at times, frozen solid at others. The cycle of ice ages has carved our mountains, filled our oceans, shaped our landscapes, and even determined the path of human history. Without them, mammoths would never have roamed, rivers wouldn't flow where they do today, and perhaps humanity itself would not exist. But now, for the first time in history, a new force has entered the equation. Us. Humans have become a geological power. We cut down forests, dig up coal and oil, and pour greenhouse gases into the sky. These actions are so vast that they are rewriting Earth's climate story. In just 2 centuries, we have released more carbon dioxide than nature normally does in tens of thousands of years. The result? A warming world, retreating glaciers, rising seas. Scientists once thought the next ice age might begin within 50,000 years. But today many argue that human activity may have postponed it far beyond that, or even cancelled it entirely. For the first time, the ancient rhythm of freezing and thawing has been interrupted. And this leaves us with a chilling irony. The very force that once threatened our survival, the Ice Age, may have been pushed away by human hands. Yet in its place we face another danger, a planet heating faster than at any point in the past. Instead of being buried in ice, future generations may be fighting against floods, storms, droughts, and rising seas. Still, Earth's story is never simple. Over millions of years, the continents will drift again, mountain ranges will rise, and the sun itself will slowly change. These colossal forces will continue to shape the planet long after humanity is gone. And perhaps, one day in the distant future, ice will march across the continents once again. Here's a thought to leave you with. Ice ages remind us that Earth is not fixed. It breathes, it shifts, it freezes, it thaws. Civilization exists only because we happen to live in a rare moment of warmth and stability. We stand on borrowed time, balanced between fire and ice. So the next time you feel the chill of winter or watch snow fall outside your window, remember, you are experiencing just a tiny whisper of the great cycles that have come before, and will come again. Because on this restless planet of ours, one truth remains: ice ages always return.